Hello and welcome to PrepTab guys. This is Himanshu and in this video I'm going to share everything that is related to geometrical isomerism. Okay, so let's start. Okay. See, let us start with the question, which of the following molecule will not exhibit geometrical isomerism? तो आपको चार molecules दिए हुए and you have to tell which of these molecules will not show geometrical isomerism. Okay, but before we start, one question that should pop up in your mind is which molecules show geometrical isomerism? What are the conditions necessary for geometrical isomerism, right? So to answer this question, let us first understand what stereoisomers are. Okay, if we talk about stereoisomers, they are isomers. And what are isomers? They have same molecular formula, matlab the number of atoms in all the isomers will be same structure, that means the bonding in both the isomers will be same, right? But the only difference will be in the arrangement of atoms or group of atoms. Okay, their bonding will be same, their molecular formula will be same, but due to some reason their arrangement, the arrangement of atoms will be different. Okay, so let us see what those reasons are. First thing, stereoisomers contains geometrical isomer and optical isomer. In this section we are only going to discuss geometrical isomer. In next section we will discuss optical isomers. Okay, so what are geometrical isomers? Geometrical isomers, again, they have same molecular formula, same structure, but the arrangement of atoms in these isomers is different due to restricted rotation. In both the isomers, the rotation is not feasible. Okay, so the rotation is restricted. Okay, like in the case of C double bond C, rotation around double bond is not feasible at room temperature. Okay, so as you can see in this molecule we have C double bond C, and on each carbon atom we have A and B substituent, right? So in this case A group, A substituent is on the same side of the double bond, and in this case A is on opposite side of the double bond. How are these different? In both the isomers the arrangement is different, right? But can we not convert this molecule to this molecule? No, because you cannot rotate. The rotation around double bond is restricted, it is not feasible. So I cannot rotate this bond to convert this molecule to this. This is not feasible. Okay, isomer in which the same substituent is on same side of the double bond is known as cis form, and in which same substituent is on opposite side of the double bond is known as trans form. As you can see over here, this is single bond, this is double bond, and these are the same substituent, so they are on same side of the double bond. Now I cannot rotate it, I cannot rotate this because rotation around double bond is not possible. Okay, and this is the trans form, guys, opposite side of the double bond. This is the trans form. Okay, so now it is clear that geometrical isomerism will take place in those molecules which have C double bond C, right? Double bonded carbon atom. Clear? Now, okay, this person has one more doubt, that is geometrical isomerism only observed in the case of C double bond C, or are there any other cases? Yes, buddy, there are other cases as well in which you can observe geometrical isomerism. Now you might be aware that what are those cases? If we have C double bond N, right, in this case we can observe geometrical isomerism. Yes, this hydrogen and this lone pair are on opposite side in this case, and in this case they are on same side, so even C double bond N will show geometrical isomerism. Or what do we need? It can be N double bond N as well. Okay, N double bond N, each nitrogen atom will have just one substituent because the valency of nitrogen is 3. Okay, and one lone pair on each nitrogen atom. So in one case they both are on same side, in other they are on opposite side. So you can get two isomers. Clear? But there is one more case. What if we have cycles? We have cyclic alkanes. I'm talking about alkanes. Okay? So we have cyclic alkanes, and in cycle the two carbon atoms of the cycle should have different substituents. Okay? Like over here we have CH3 and CH3 on two different carbon atoms. So in one case CH3 can be on opposite side of the ring, and in other CH3 can be on same side of the ring. So this is cis and this is the trans form. Clear? As you can see over here, we have a three-membered ring. This is a three-membered ring. In this three-membered ring, two carbon atoms have substituent CH3, and this is the hydrogen atom. So they are on same side of the ring. This is the ring, this is the plane of the ring, this is on the same side. So this is cis. Now I cannot rotate it. The rotation is not feasible, it is restricted. Okay? So a different form will also exist of this molecule, that is the trans form. You can see it over here. This is the trans form, opposite side of the ring. Okay guys? So guys, I hope this is clear that which molecules will show geometrical isomerism. Okay? Now it is also very important that you know, that you are aware which molecules will not show geometrical isomerism. Right? Okay. So which molecules will not show geometrical isomerism? If in a molecule you have C double bond C, and on the same carbon atom both the substituents are same. If in C double bond C or C double bond N, on the carbon atom, if both the substituents are same, then this will not show geometrical isomerism. Okay? Now this carbon can have anything, same or two different atoms, whatever it is. Since this has same atoms or group of atom, this will not show geometrical isomerism. Same is the case with the ring. If I have a ring, let's say this, and on single carbon atom I have Cl, Cl, and over here I have Cl. Since on the same carbon atom we have chlorine, same substituent, this is not going to show geometrical isomerism. Okay? So I hope this is clear. What if alkene is present in a ring? Now as I said that the cycle should be an alkane, it should not be alkene, right? Now what if the ring has double bond? Then will it show geometrical isomerism? Yes, there are cases when even in ring, when you have a double bond, you can observe geometrical isomerism, but the condition, what is the condition? The condition is that the ring should have 8 or more carbon atom. Okay? The condition is a ring containing double bond will show cis and trans form only when it has 8 or more carbon atoms. Okay? This has 6 carbon atom. Now you can observe the cis form of this alkene. Of this alkene we have cis form, but trans form is not possible because you cannot rotate it. Okay? So trans form is not possible, only cis form is possible. So we cannot say that this is showing geometrical isomerism. But this is an 8-membered ring. In this you can see both the hydrogens are on same side of this double bond. In this case they are on opposite side of the double bond. So this is your trans form and this is your cis form. Okay? Because rotation is not possible in smaller rings, that is why they are not, trans form is not visible in them. Clear? So this is all about geometrical isomerism. Now let us go back to our question. Okay guys, which of the following molecule will not exhibit geometrical isomerism? Okay, first let us quickly draw the structure of these molecules. 1 pentene, 1 chloro, 3 bromo, then 2 pentene. I hope you guys are solving it with me. Then we have cyclohexane, 1,3 dimethyl, and butene, 2 methyl bromo. So this is CH3, this is CH3. In these four molecules, which will not exhibit geometrical isomerism. When we have an open chain, we see double bonds. So we have double bond over here. Over this, on this carbon atom, we have hydrogen and Cl. On this carbon atom, we have this group and hydrogen over here. So yes, you can have cis and trans form both. In this, you have hydrogen on opposite side. You can also form a molecule in which hydrogen is on same side. So this will show. In this, you have CH3 on same side. Other can be CH3 on opposite side. So this is also going to show geometrical isomerism. These are cyclic alkanes, as I have already discussed. Yes, this can show cis and trans form both. So this is the only option left, which is your answer. But what is the reason? The reason is that on the same carbon atom, you have two same substituents. This will not show geometrical isomerism. Clear? Now the next question is the correct order for the given pair of isomers. Basically, we are given cis and trans form of some molecules, and their properties are given to us. Their physical properties are given to us. So we have to tell what is the correct order. What about melting point? Melting point of trans form is more than that of cis form. Why? Because in trans, better packing of molecules is there. Efficient packing is there. Efficient packing means less voids. So area in contact will be more. Hence force of attraction will be more. Okay? That is why trans has higher melting point than cis. Clear? So what are we given? This is trans, this is cis, but this is wrong, right? That cis has more melting point than trans. This is wrong. What about dipole moment? In case of dipole moment, cis has higher dipole moment than trans, right? Because in trans, the substituent is on opposite side. So the dipole moment of this bond will cancel out the dipole moment of this bond. So in trans, mu net will be 0, right? But in cis, you can see in cis, the dipole moment will add up. So this will have some dipole moment. Clear? Or we can say this molecule is polar and this is non-polar, right? So cis has more dipole moment than trans. So this is your cis form, this is your trans form. Obviously this is wrong, not correct. Boiling point. Boiling point depends on force of attraction, and we have already said that cis is polar and trans is non-polar. Non-polar molecules में किस तरह के force of attraction होते हैं? London force, right? London force of attraction. And polar में there is dipole force of attraction. Which one is stronger? It is dipole. Dipole is stronger compared to London force. So that means boiling point of cis is more than trans. Okay? So this is trans. Okay, this is also wrong. So this is also wrong. Obviously again, this is the right answer. Water solubility. Solubility के लिए there is one rule. Like dissolves like. Polar में dissolve होगा. Non-polar में dissolve होगा. Okay. Water is a polar solvent. So which one is polar among these two? Cis is polar. So cis will have higher solubility in water compared to trans. Okay? So you can see this is trans, this is cis. Cis has higher solubility. So yes, it is correct. Okay. Next question, how many geometrical isomers are possible for the given compound? Geometrical isomers की बात कर रहे हैं तो डबल बॉन्ड देखो, या तो C डबल बॉन्ड C डबल बॉन्ड N और N डबल बॉन्ड, और cyclic alkanes पे substituent देखो. If we are talking about cyclic alkenes, तो ring should be 8 or more than 8 carbon atom. This is the rule. ठीक है? तो first C double bond C, yes. C double bond N, ठीक है? Yes, we have an alkene and the ring has how many carbon atom? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon atoms are there. So this will show cis transform both. Cyclic alkanes, don't forget this. They both can show cis and transform. We have hydrogen over here and hydrogen over here. So one time hydrogen can be on same side, other time hydrogen can be on opposite side. So these are also going to show geometrical isomerism. Okay, so how many pairs do we have? 1, 2, 3, 4. And what is the formula, guys? 2 to the power 4. That means 16. So this should be your right answer. Okay. Quickly revise the formulas to calculate the number of geometrical isomers. If the molecule is unsymmetrical, then it is 2 to the power n, where n is number of double bond or geometrical centers. See, like I have counted this as one geometrical center. Okay, this as one geometrical center. If the molecule is symmetrical, then you need to see whether n is odd or even. Okay, if it is even, then you are going to use this formula. If it is odd, then this formula. Clear, guys? Now you have completed all the dimensions of geometrical isomerism. I hope you guys enjoyed the video. So please do like, share and subscribe this video, and thank you for watching, guys.